I'm going to showcase the work of some of my wonderful students. I wish I had time to showcase all of them, but I can't. So I'm interested in how the mind talks to itself. So this is going to be decidedly low-tech. When thoughts overwhelm the mind puts them into the world. So the first study putting them into the world allows us to see our own thought, to organize our own thought, to revise it, and to embody our own thought. So it's thinking in a different way from just abstract. So the first project I'd like to tell you about was a project by Eliza Bobek, and she was teaching middle school science. She taught students, one group of students, a bicycle pump, how it works, another group, chemical bonding, a little harder. After the unit, she tested their knowledge. Then half of them created a visual explanation of what they had just learned, and the other half created a verbal explanation. This is the normal way of testing. So after they'd created the explanations, and I'll show you some now, their knowledge was retested. So what were the effects of the, this isn't working, there. These are some of the visual explanations they made of chemical bonding. Here's one. Here's another using, it's almost a comic strip, using sharks to explain it. So you can see that the students made up their own visual explanations. They weren't parroting what they had seen. Here's another one, there. And this one is a little more friendly. It has people giving and sharing electrons. And this one has boiling pots. So these were spontaneously produced by the students. We found, and let's see, there. These are a couple of the bicycle pump. Another one gives you step by step. These are the words. Okay, one word after another. So as I said, the visual explanations worked much better. In fact, they contained far more of the information. Both groups improved without any intervening teaching. Just by making the explanations, they got better. But the visual explanation group improved far more than the verbal explanation group. So why might that be? The visual explanations provided a natural mapping from the space of the STEM world to the space of paper. The visual explanations also provided a check for completeness, or all the parts there. It's harder to do when you just have words. It provided a check for coherence. Do the way that I've depicted it, does it make sense? And you have a visual way of testing that, which again you don't have with the words. Finally, the visual explanations provided a platform for inference. They could look at the diagram that they had created and think about what it might mean. So for these reasons, we think visual explanations are especially effective. So what about sketches for exploration? These are sketches for learning, and we've found that artists and architects use sketching as a way of exploring ideas and a way of discovering. So architects will put something down. This is a practicing architect. Will put down things in a very elementary, rudimentary sketch, and then re-examine their own sketch and find things that they didn't intend, like patterns that they didn't intend but just show up, or like they'll all of a sudden see the traffic problems that they didn't anticipate. In these cases, the sketchiness of the sketch is crucial for discovery. The very ambiguity allows multiple interpretations and allows discovery. So whereas in science we might want clarity, if we're sketching for putting our ideas on paper for exploration, the ambiguity is helpful. And Julia Chow, a current student working on her dissertation, is looking at ways of increasing people's interpretations of sketches. She's been giving these ambiguous sketches to people, asking them for as many interpretations as they can give, and then giving hints. And she's finding that various kinds of hints, in particular conceptual hints to search other kinds of things, help people find more interpretations and lead to more more creative and more useful uses of the ambiguity. Artists also explore and make discoveries as they draw. Andrea Kantrowitz is currently finishing a dissertation joint in art education and cognitive studies. She's been interviewing a number of practicing artists on how they use their sketches for, again, discovery, for innovation, and so forth. What's especially interesting about these artists to me, I mean, again, they're using the ambiguity in the same way the architects were, but the conversation isn't really verbal at all. It's going between the hand and the eye. They're seeing things and drawing things, but they're not, it's hard for them to articulate what's going on. So it's a different kind of conversation, a visual spatial conversation, and not our typical verbal one. But again, this is how artists practice, and it's very productive for them. So again, we visualize thought by putting it on paper. We want clarity for instruction or for learning, and ambiguity for innovation and discovery. What do you do if you don't have paper? So this is what brought us to gesture. Paper is a relatively new invention, and cheap paper certainly newer. So what do you do if you don't have paper? And the answer is you use your hands and your body. So these are studies I'm going to describe and show you, studies briefly that have been done by Azi Jamalian, who's here, over in there, and she can wave, and Valeria Giardino. They put people alone in a room, and the people read descriptions of space, say a gym where you might work out, or an amusement park, or a small town. And they were told that they needed to remember these descriptions because they would be quizzed later. So let me show you two of the students reading. Can you start the video? So this is one. So look at her hand. She's reading about space. She's not looking at her hands. She's reading. She's thinking with her hands. And you can almost see the kind of map that she's drawing of the space that she's reading about. Okay, I'll show you one more. Please, can you start the video? And you can see gestures are quite different, and she's even moving her body, trying to imagine what she's reading. Again, not looking at her hands. The thinking is in the body. So we found that about 70% of our subjects do this as they're reading. Those that do it remember better. And those that gesture remember better the trials on which they've gestured. They had many trials than the ones they didn't gesture. So the gesture, and we've replicated this in other studies, so these movements of the body are serving multiple purposes. They're offloading memory. They are structuring memory. You can see they're setting up a real model, not just a mental model, but it probably helps them with a mental model. And it's providing an embodied cue. So it's a bit mysterious, but if I ask you, where's the X key on a keyboard? Okay, how do you answer? You probably answer with your hands. You don't know visually where it is. And if you're a skilled musician, you're looking at the music, and your body's enacting the music. So we do these sorts of things, perhaps not realizing it, in many cases, many ways. It's become a familiar sight to see people talking on their cell phones and gesturing like mad, even though there's nobody there to see the gestures, right? And we no longer think these people are crazy. We know that their gesturing are helping them think. Okay, they also help others. And this is work with Sukhman Khan and John Black, who's also here. Sukhman showed half his subjects a video explaining how an engine works with action gestures. He showed the other half a video with structure gestures showing the structure of the engine and of the parts. Now, gestures are action themselves, so they have a unique role in expressing action. And when students read about STEM phenomena, structure is relatively easy for them to get, but action is much, much harder. So we thought these action gestures would help. So same verbal explanation, just either with action gestures or with structure gestures. So when students had the action gestures, they answered more questions correct about action, even though they could answer them only from the verbal script. They showed more action in diagrams that they made later. They made videos also of the explanations. They used more action gestures, and they used more action words. And as before, their action gestures weren't imitations of what they saw. They were their own inventions. So these are some gestures of the students. I don't have movies, sorry. These are those who saw structure gestures. These are their diagrams. These are the diagrams of people who saw action gestures. So you see there's far more action depicted, and they learned far more action. So those gestures had a long-term effect. So my message is to visualize thought, and we have done a little bit of work, or my students have, in translating this into technology. Ozzy's worked on that. You can question her later. We have other students who've translated these sorts of gestures into technology, into touchpad technology, and also into sketching technology. So thank you very much.